again, thank you for joining us for this session. Feel free to scan the QR code for any questions and be sure to sign in so you can insert your question on the chat. And please join me in welcoming our speakers, Sam Kemp and Yufeng Li.
Thank you. Thanks for coming to this talk. In this session, we're going to show you how to create GenAI experiences in your applications using Phi and the ONNX ecosystem. I'm Sam Kemp. I'm a program manager in the AI frameworks team here at Microsoft. And with me co-presenting today is Yufeng Li. Yufeng, would you like to introduce yourself?
Yeah, sure. Thanks, Sam. I'm Yufeng, software engineer manager from AI framework team.
Cool, lovely, thank you. And a quick show of hands before we begin. Has anybody here used the ONNX Runtime in their applications at all today? Like, quick show of hands, or you can cheer. There's a few of you. Has anybody here used 𝗦𝗲𝗀 at all to sort of optimize models? Okay, there's a couple of regulars maybe that have done that. So what we're going to do in this session is we are going to give a sort of gentle introduction to the ONNX ecosystem for you before we sort of deep dive into a demo and show you really how to kind of use it. Okay, so without further ado, let's get cracking, right? So the way to think of the ONNX ecosystem is really there's three core elements to it, and we call this kind of like a trilogy, right? There is ONNX, which is an intermediate representation, and ONNX stands for the Open Neural Network Exchange. This came out in about like 2017, and the idea behind it was that you could take a model that had, say, been created in TensorFlow and run that on PyTorch. And then quickly soon after, what we then sort of built out was the ONNX Runtime, and that's when Yufeng sort of joined the team in about 2018. And this was to take those ONNX models and run them fast and efficiently on an engine, and then sort of training was also built into that. And then what we started to see is that, particularly internally, users started to sort of do the dark arts of tweaking models to really get them to go with high performance on the ONNX Runtime, and it's quite a lot of manual work. So then we introduced 𝗦𝗲𝗀, which stands for ONNX Go Live. And this is a toolkit that really sort of makes that more automated in terms of getting a model that will run with high quality and efficiency on the ONNX Runtime. And so we're kind of going to refer to these three things in today's session. So like who's using ONNX? So internally at Microsoft, it's used in a lot of our products and services. So even if you haven't used ONNX Runtime in your applications, if you use these products or services, you've probably been using ONNX without knowing it. So it drives many of the ML capabilities in these products and services. And then outside of Microsoft, there's also a community out there that's also contributing. So for example, like at Hugging Face with the Transformers JavaScript library, and also the hardware providers as well that you see down at the bottom there. They're sort of contributing to make sure that ONNX runs fast and efficiently on their MPUs, GPUs, and CPUs. And so why do we sort of see this sort of momentum around ONNX? Why are people using it? And one facet of this is there's just a breadth of frameworks and a breadth of deployment targets. So you can see here on the left-hand side, there'd be a training framework that can pop in there. And on the right-hand side, there's a deployment target. And what's consistent between these is that you are going to use 𝗦𝗲𝗀 to optimize a model from a training framework. That will give you an ONNX artifact that will then run fast and efficiently on the ONNX Runtime. And so we can sort of plug in these empty boxes. So for example, we could have a deployment target of Windows 11. And the ONNX Runtime is going to run on what we call an execution provider called DirectML. And that will then hit the GPU or MPU. But equally, what you could do is you could say, well, I want the deployment target to be like a Linux VM in the cloud or Kubernetes that could be running NVIDIA CUDA. And it's the same process. You use 𝗦𝗲𝗀 to generate this sort of hardware-aware optimized model for CUDA, and then that will run on the runtime. And you haven't had to learn CUDA and the sort of inner workings of CUDA to do that, and you haven't, in the previous example, had to learn like direct ML. It's just this one sort of consistent way of producing these models. And like TensorFlow is supported, but also like classical ML as well with like scikit is also supported in this system. OK, so well, that's one facet of the breadth of frameworks and breadth of deployment targets. But another facet is the performance as well that you get with the ONNX runtime. And Yufeng, I'm going to hand you the clicker for you to run through this part.
OK, thanks, Sam. Just like Sam mentioned, ONNX runtime support the broad target, but also can provide the leading performance for those target with corresponding backend. So for Windows developers, ONNX runtime and DirectML can provide a good performance across a broad selection of hardware accelerators, and also can simplify how you distribute your apps on Windows. Fast3 mini model is small but powerful. It is very suitable to deploy in client or embedded in your application. ORT with DirectML is able to get 250 tokens per second for Fast3 mini model on RTX 4090 GPU, which is super faster. And even on older device with GPU that are not suitable to run a Fast3 mini model, like if your GPU only have 2 GB GPU RAM, on those devices, you can still run with the ONNX runtime and the CPU backend to get 15 to 20 tokens per second, which is also well above the human reading speed. If you run on the Linux, ONNX runtime and CUDA can also provide the leading performance for both quantized and non-quantized Phi 3 model. So the diagram shows ONNX runtime with CUDA can also provide the leading performance comparing with PyTorch or Lambda CPP. So ONNX runtime web recently added the support of web GPU, which can enable user to run the Fast3 model in web browser. So our PM, Emma, will have a demo dedicated to this tomorrow. Welcome you to join. We recently also optimized have a big performance improvement on the mobile, and it's also enable user to run the Fast3 mini model on mobile. For example, on the Samsung Galaxy S21 device, you can get around 10 tokens per second with only CPU. That is also about the human reading speed. It's pretty good. ONNX runtime support a broad target with good performance, but the generative model are stateful. However, ONNX runtime still is library. It cannot keep the model state. So you need to handle the model state like the KV cache, attention mask, position update, those kind of things by yourself if you use ONNX runtime. So it is annoying to the user, to the developer. To tackle this issue, we built a new component, ONNX Runtime Generative API, on top of ONNX runtime. It can handle the model state, like the update the KV cache, also update the attention mask, position ID automatically. In addition to that, ONNX Runtime Generative API also have the embedded tokenizer support. It also have the sampling support, like the top P, top K, and gradient search, beam search, this kind. So it makes the user to be easily to run a language model, a generative model with ONNX runtime across platform and with this cross-platform support, and also it supports multiple language. We will have a demo to showcase how easy you can use ONNX Runtime Generative API to run the Fast3 model later. Back to you, Sam.
Okay, thank you. So up to this point, we've mentioned 𝗦𝗲 quite a bit about this kind of like it optimizes a model for some sort of like target hardware. And so we're just going to kind of lift the lid and go into a little bit of depth on 𝗦𝗲 now. And sort of like if you sort of take a step back and think about the problem space when we're trying to ship a production model in our application, we tend to think about three key metrics, right? One is sort of the accuracy of the model, like we want to deliver a good user experience on that, the latency, and the throughput. And what we're having to sort of trade off is sort of user experience. So we want highly accurate models and delivering the lowest latency. But we have to sort of temper that often with the cost, right? So if we have higher accuracy and that leads to higher latency and lower throughput, then the cost goes up. And we're trying to sort of balance these two things when we go to production. And that's pretty hard. Like one, there's not really much tooling around to kind of help you do that and understand that trade-off. Also, you need to then go and learn like very specific toolkits for deployment scenarios, whether that's like CUDA or ROCm, to sort of really drive the performance. You have to balance the accuracy and efficiency within the hardware constraints. And also, it's a very like rapidly evolving hardware landscape. And I guess like these last couple of slides, I've been sort of teeing you up for the rationale for 𝗦𝗲, right? So 𝗦𝗲 is this easy-to-use toolkit that allows you to build out model optimization workflows. And the key thing to sort of take away about 𝗦𝗲 from this session is if you were to say, I want to find the most efficient model for inferring on the cloud or edge, whilst taking into consideration accuracy and latency requirements. And you can also have like throughput as well. And it will kind of go off and it will find that optimized model for you to meet those targets. It's like that's the key idea of 𝗦𝗲. And it has in it like a number of like the hardware optimizations built in and graph optimizations. And that really sort of reduces the engineering effort when it comes to sort of having to run this without learning specific toolkits. So here is an example of an 𝗦𝗲 workflow. And what you can see here is that 𝗦𝗲 can also handle fine-tuning as well. So in this particular case, what we're doing is we have in this workflow a number of passes. And here there's like Clara fine-tune, so it would go and fine-tune, convert to the ONNX format. It would run some transformer optimizations and do some quantization. And we're going to plug into that workflow like a data set and a model. And in this case, it could be Phi3. And we also plug into 𝗦𝗲 what are the requirements that we want on terms of latency, accuracy, throughput. And it will go and do like it could be an exhaustive search in this case to go and find the optimizations that are required to give you the best candidate model for the target. In this case, it's DirectML. But equally, like you could change Phi3 in this case if you wanted to, because there's a plethora of open source models out there that you could try, and you could plug in different models, run the same process, and get the best candidate model for each of those open source models, and then you can pick the one that meets your requirements. And what comes with 𝗦𝗲 is that you can represent this whole workflow in a JSON configuration and then run it over a CLI command like 𝗦𝗲 run here. Now, we're kind of making that a bit easier. So you may have heard yesterday that we announced the AI toolkit for VS Code. And part of the toolkit is that it enables you to fine-tune and optimize your model. And it's doing that with 𝗦𝗲. And we're going to show you this in a second. But also it should be noted in the toolkit that it allows you to download and experiment with models locally. Again, we're going to show you this in a second, but that's all running on the ONNX runtime. So we're going to get into the demo, and the demo consists of 3 parts. So in the first part, we're just going to simply show you how to go and download file locally, build out an application, and we're going to use the AI toolkit to do that. And then in the second part, we're going to show you how to go and fine-tune the model, Phi3 in this case, for a number of different skills. And again, we're going to use the toolkit to do that for you. And then we're going to take those model artifacts, and we're going to show you how to put that into an application and hot swap between different adapters. Okay? So without further ado, I'm going to switch to the demo machine. OK, so here we are in VS Code that we all know and love. And the way that you install the AI toolkit for VS Code is just like any extension. You go into the marketplace, you select install. And once you've installed it, what you'll see on your kind of primary bar here is a new icon that appears for the AI toolkit. And that's divided into models. And you can see I've downloaded a couple of models already, and also sort of various capabilities for playing with those models and also fine-tuning them. And so what I'm going to do is I'm going to go into the model catalog here. And at the moment, we support like Mistral and Phi3 in the catalog. We are building this out with more models that you can run locally. And in this particular case, because I'm running on a Windows machine, and this is a Windows machine in the cloud, so it's got an A10 GPU on it, it's just pulling all these DirectML optimized models for me automatically from Hugging Face. And what you can see here is that you go and select download, and that will take as long as you've got bandwidth. But previously, I've downloaded like Phi3 Mini, so we can go and load that in the playground. So like I say, this has been optimized for DirectML, and then I can ask it like a question. So this is just to kind of experiment with the model, so I can sort of say like, what is the golden ratio? And you can see that this comes back pretty quickly on this A10. Yeah, so this is hitting about sort of 60 to 70-ish tokens per second. And so you can sort of play with models in this way. You can go and switch models. So if you wanted to go and try like Mistral, you can do that. And this is all running on the ONNX Runtime underneath the covers. And we expose this as a web server. So what that means, if I sort of switch to a little application here. So this means if you've ever used the Azure OpenAI .NET library, what you can do is, because this has got a local web server, you can plug in the endpoint to be on that local host. And it runs out of off of port 5272. But you can change that in the extension if you want to. And you can also then plug into the deployment name the name of the model that you downloaded. And this web server is all using the OpenAI format, so it's compatible with that. So let's go and just run this application so you can see that it works. We'll do it without debugging. Confidence is pretty high, he says. So this will go and run. So it loads in the model, and it responds with the answer, again, at a pretty fast token rate. Now, this method is pretty useful if ultimately your endpoint is going to end up in the cloud, right? So you might use the Azure AI Studio models as a service with Phi3. And what you're after is sort of like a tight dev loop, just sort of running the model locally before you switch to the cloud endpoint. And that might be because maybe you're going to get a subscription and you're waiting for the subscription to use. And it just unblocks you in terms of getting your application together. But if your end goal is to take this model and put it into your application so that it runs like on device, right? Say, for example, a Windows app, then this is where you'd use the ONNX Runtime GenAI API. And I'll show you what that looks like here. And Yufeng's going to sort of take you through the code, because he is the engineering manager that did develop this. So he's probably best placed to kind of talk you through this. Yufeng, do you want to talk through the code here?
Yeah, sure. So just like we mentioned earlier, and so with this new ONNX Runtime Generative API, it enables you to run the language model easily. So if you look at the code, it says you just need to provide a model, and then we can create a model with this model path. And ONNX generative API also provides the embedded tokenizer. You can create the tokenizer from the model. And once you have the model and the tokenizer, you can start a for loop to get the user's input. And then you can compose the prompt with user input. Once that's done, you can with generative parameter API, you can create a generator to generate a response. You can set up different kind of parameter, like the sampling method you want to use and the maximum length, thing like that. And once the generator is created, so it has another loop to generate the one token by one token. To generate tokens is also quite simple. Get the compute, generate the next token, and once you have the token, you use the tokenizer to decode the token. Yeah, that's it. And with
so it's about sort of 15-ish lines of code, isn't it, roughly?
Yeah, 15 lines of code. If it's you just kind of the code to really run the model is 10 lines of code. You're able to start to use ONNX Runtime GenAI to run the model.
Cool, and let's run this. So this actually runs a model that is been optimized for DML again. So we'll hit the old debug, well, without debugging. So this is just a simple console app. So again, it loads the model in. It loads pretty quickly. So I need to make this a bit bigger.
Yeah, the model loading is also fast.
And that's actually specific to DML. So if you actually load onto CPU, it takes a bit longer to load onto CPU, but with DirectML, it's very fast at loading.
Yeah,
at loading
with
the model.
our latest package, it is also faster than before.
So you can sort of see here, again, like getting pretty high sort of tokens per second. And I think like if you do coding on Phi3, if we say like write a linked list in C#, I think coding tends to go a bit quicker as it hits something there. So you're almost clocking at 75 tokens a second. So this.
Yeah. So we also have the Python and C++ C API.
Yeah.
And Java and Object-C. Java is also in progress.
And I'm right in thinking if you want to also do this on the web, it's the same API that you use for the web as well.
Yeah,
and
the
mobile.
web is also on the roadmap.
Okay, got it. And what about mobile as well?
Mobile is you can use Java or the C API. The Java is in progress. The C is already supported.
Okay, lovely. Yeah. Cool. Okay, so that's these. What we've sort of shown here then is a couple of ways of baking in Phi3 into your application and showing the playground. What we're going to do is we're just going to head back to the slides because we're going to show fine-tuning. Do you want to hit A? That's the one. But before we sort of go into the code, it's probably a good idea to just kind of context set what we're going to do. So is it, a quick show of hands here. Is it anybody done fine-tuning before or fine-tuned a model? There's a few of you. OK. Cool. OK, so the sort of common scenarios, if you haven't ever sort of fine-tuned before, is really around sort of improving the reliability of the results that you get from the model. So some examples might be like putting in like domain-specific knowledge. It could be entity extraction, setting the style and format of the responses, correcting failures. But another sort of scenario is classification. An example here is on the right-hand side. Hopefully it's big enough. Yeah. So what we're sort of set here is in the context information, a sort of system prompt which says, you classify phrases from users into sad, joy, fear, and you only respond with a single word. And what we plug the user prompt here is asking about, saying about cricket is a wonderful sport to play. Now, we all know that cricket equals joy, and it does come back with joy, but it also gives us some additional response that is sort of undesirable. It over-responds and starts to come in with instruction 2 and something that's just completely unrelated. And this is like a classic case of what we would want to fine-tune out, right? That we just get this single word. And we're going to show you how to do that using the AI toolkit again, which is running Olive. But we're also going to show you that we can create these other skills as well, not just the phrase classification in the middle, but we can also create other skills around answering coding questions and producing high-quality responses. And we're also going to do prompt intent as well. So we can take a user prompt and then classify that into whether it is a phrase or a coding question, right? And the reason that we are doing this is so that we can show this hot swapping of adapters. So what we will load in to memory are 4 things. We have the base model, right, which is Phi3 mini, and that's around 2 gigabytes. And we're fine-tuning these adapters, but they are like teeny tiny in comparison to the base model. They're around 25 megabytes, right? So you can extend the skill set of Phi3 with these adapters without really pushing the memory footprint of the application. And what this allows us to do is to do something where we can take the user prompt here, like cricket is a wonderful game. And so that's going to come into like a simple router. And the router will take the prompt, and it will go off to prompt intent. And the prompt intent will come back and say, well, this is phrase, right? And so what it will do is the router will go, OK, now I'm going to pass the prompt to the phrase classification. And again, cricket equals joy, so joy comes back as the response. But equally, like then if a user prompt comes in and it says, like, add 2 numbers together, the router can go off. It goes to the prompt intent classification. We get the intent as being coding. And guess what? It passes it off to the coding adapter, and you get a response in code. Now, you can also extend this sort of further on the prompt intent, because here we're using Phi3 mini locally with these adapters. But you could have a kind of catch-all that might be where it goes off to an LLM in the cloud with OpenAI, which captures all the other user prompts that kind of come in. And you can do this on-device prompt intent classification. So this is what we're going to show you now. So let's, oh yeah, if you hit C3, there we go. OK, so we're back into VS Code. I'm just going to switch my window across here. So the extension provides a way of generating the Olive configuration for you through a user interface. So you would come into the AI toolkit and select model fine-tuning here. And then this brings up like a few steps that you have to do. So you have to give it a project name. So I'm just going to call it like my demo. And then you have to give it a location on your file system. So put that into code. And then you have to select a model. So here we're going to select Phi3. And then we're going to select configure project, if I can hit the right key. And what you're seeing here is this is downloading a template for you that will run fine-tuning, but also it will give you the template to sort of inference that fine-tuned model as well. And what you have to do here is you have to give it a number of settings, and these settings will correspond to the Olive configuration to run this workflow. Now you'll see here that you can select fine-tune locally. So if you have on your device an NVIDIA card, you can fine-tune locally, or you could equally do this on a cloud VM as well. But what I'm going to show you is something that will be coming very soon, which is where you can offload the fine-tuning into Azure Container App Service. And the benefit over a cloud VM is it's ephemeral compute, right? So it's just going to spin up a job, pull a container, and run it, and then spin down when it's finished. So we'll kind of show you this in action. And one of the things you have to sort of provide is data. The template that we provide does give you some data to use, and it's actually that phrase classification one. But equally, you could go in and you can browse like your local file system and add a data set there. You can also add a Hugging Face data set. And what this data set will consist of is what would be the user prompt and what would be the response to that. Now, getting that data, you can actually use like large language models to generate synthetic data, like GPT-4 is pretty good at this, and then fine-tuning your SLM. That's like one method. There are other tools as well, like there is like Gretel AI that will do synthetic data generation for this task that are also like good to use. And so once you fill in these settings, you hit Generate Project, and then we're going to relaunch this in the workspace. And what you'll see here is that in the project, it has, hang on, just close some of this additional stuff down. What it's generated for us is a bunch of folders with, if we click on the fine-tuning one, all the settings that you provide in the previous pane get injected into this JSON configuration file. So you can see like there's the data configs. So this is all the Olive configuration. And you see here it's got the ChloroPass to do the fine-tuning. It also provides for you like how you would go and inference this. So there's like a chat application that you can use. What we're going to show you here is how the adapters can kind of work on the ONNX runtime. Now, I mentioned that we can go and train this in the cloud, and you need an Azure Container App Service to do this. Now, you can use the Azure portal to do that, but the extension, the AI toolkit, can also do that for you. So if we go to the command palette, there is a provision Azure Container Apps job for fine-tuning. We can select this, and it's going to ask me a bunch of the typical sort of Azure questions, like what's your subscription? It'll also ask me for a resource group, so if I just put something in here, like that. And then, has it done it? Why? Oh, hang on, let's try that again. Okay, we do the subscription, new resource group. Okay, and then you choose the location. And West US 3 is supported. There's a couple of other regions, but I can't remember them off the top of my head. We'll try and dig those out and put them into Pubble for you. But if I select West US 3 here, it's going to initiate an Azure deployment for the service. I'm not going to do that because it takes about 5-ish minutes, and we won't have time for sort of Q&A and all of that good stuff. So I'm going to sort of escape from here. But what I'm going to show you is like what that would produce, like in here's one I made earlier. So once that's all deployed, what will happen is it will inject into a configuration for you all the information around like the sub ID, the resource group, and the Azure Container App name. And you'll also see here that it's going to go and run a command like the Olive command with the phrase classification skill. And if we just look at here at what I've changed in the phrase classification skill is I've updated this to be targeting the target system to be a DML execution provider. And so we'll get an optimized model for DML. And so we can go and run this in the cloud. If we go to the command palette again, there is a run fine-tuning. And it's going to upload the files here. I'm just going to get this up. It will start the job. And then it'll ask me, like, the job has started. You see that's pretty quick. So it tends to be within around 10-ish seconds that the job will get going. And then you can stream the logs back either into the portal or you can see it directly in VS Code. And so this will create a connection to that. You'll see that it's successfully connected to the container. And the output of the job, it'll poll the job, I think, every sort of minute and come back. Now, one of the good things that Olive will do for you is it does a lot of caching. So if you might submit a job with maybe a few epochs to kind of test something out, it will checkpoint all of that for you. And so if you rerun the job, it won't start from scratch. It will start from the last checkpoint. And it also does a bunch of caching as well around the workflow. So if if later on you want to go and change something in the workflow, it doesn't have to rerun the fine-tuning, which is the expensive part. And so you sort of, unfortunately, it doesn't quite show up on the screen because of the resolution, but it's gone off and it's run everything. It was super quick because of that caching mechanism. But typically, again, it depends on the GPU that you're using and the number of epochs, but it can take around about 40 minutes to an hour and a half to run a fine-tuning job. OK, so at the end of this, what we get out are a bunch of model artifacts that we can bake into our application, right? So let's show you that. Again, let's swap out the screen here. So in this application, and here I'm using Python to just demonstrate that, that we do have these different language bindings. Again, we're using the ONNX Runtime GenAI API, and we go and load in all the adapters. So if you remember that slide with the base model, we get that loaded in. We load in the 3 additional adapters. So that happens in this initialization phase. And then the only difference to what Yufeng showed you in the first example of the ONNX Runtime Generate API is that we have this extra parameter, which is to go and grab the adapter weights. Okay, so it's like an additional 2 lines of code that we've added previously. And you can see the Python API is very similar to the .NET API as well. Okay, so let's run this. Let's see. Okay, so I'll move some screens around here. Okay, so CD. So I'll just activate a Conda environment, and then we just do Python app. So again, it initializes, so at boot up time, it's loading in the model and adapters. We can enter in a message here, say, like, cricket is a wonderful sport. So you can see here that the router, which is showed in green here, it's done the prompt intent adapter. That's come back with, OK, this is a phrase that the user wants to get classified. So then it's pushed it onto the phrase classification adapter, and lo and behold, it's come back with joy, which is correct. And you can see that there's no additional information that it's provided. Right, it has come back with the single word answer, and that's because we fine-tuned it. And then equally, we can add in add 2 numbers in C#. Again, it's going off to the prompt intent adapter. It detects, OK, this is a coding question. And then it goes off to that coding adapter, right? So this shows you how you can kind of extend the capabilities of Phi 3 in your applications and run this on device. So we'll switch back to the slides, which I think, yeah, A1. So we've shown this application. I think we're sort of closing out. We're getting close to sort of Q&A time now. So just so that you know, there's some related sessions. As Yufeng mentioned, our colleague Emma, she's going to show you how to optimize the AI models with the ONNX Runtime in a demo tomorrow. That's 4:30. And there's also a couple of lab sessions that you can attend as well to get kind of hands-on. And I believe, oh yeah, there's one more slide with some more details. And I think you can sort of download these from the session. Oh, sorry, did somebody want to take a picture of that? There we go. Sorry. Cool. And on these examples, on these websites, you'll find examples to the things that we've shown today. So you can sort of download those and get running, putting Phi into your applications. Lovely. OK, so yes, we're bang on time. 5 minutes for Q&A. So yeah, if there's any Q&A, I think there might be a microphone if you come and ask your questions, or we'll be sort of hanging around at the front here if you have any questions that you want to ask. Thank you. Thank you very much.